Hello, everyone, and welcome to Innovation Coffee, brought to you by ARM. My name is Robert Wolf, your host for today and every week going forward and into the past. Be a little silly here. But yeah, so today we have an amazing episode planned for you. What's up, Sebastian? Welcome. Welcome, Potting. Welcome, everyone, all the members of the community. RJ, it's awesome having you all here. So today we have a great episode planned with an amazing guest, the founder of Espruino, Gordon Williams, who will be talking to us about everything Espruino. In fact, he also brought some really cool demos to show us as well, which we will be trickling into the show throughout our main segment. Now, as we usually do, of course, before we dive into the main segment and welcome on our guest, our featured guest of the day, I would like to first talk about last week. Now, last week, it was really fun. We spoke with Richard Elberger, who's an IoT principal technologist at Amazon Web Services, also known as AWS. There was a lot of cool stuff talked about. He joined us for the whole hour. I didn't think we were going to be able to fill the whole hour, but we did. I'm going to share the link here, last week's episode. Post that right there. Don't go clicking it yet. Wait until after this episode, and we will, and you can go, if you have an extra hour of your day, go check it out. All right. Now, of course, these days leading up to ARM Dev Summit, we do have quite a bit of news. This just in, my whole thing kind of flickered here, my whole screen. Okay, this just in, not really, but we've been talking about this every week. ARM Dev Summit is literally right around the corner now. It's gonna come so fast, right? So October 19th, 20th, and 21st next month, less than a month away. devsummit.arm.com. Go there and register. Like, if you aren't already registered, this is a free event. There are tons of technical sessions, workshops, panels, community areas where you can hang out and meet with your fellow developers. There's just so much cool stuff going on there. And if you don't register, you won't get to go. So go register, go check it out. Not only that, I heard that they're also going to be releasing ahead of time, like, access to a nice range of tech sessions, like a couple weeks beforehand or something. So you'll get access to some of the pre-recorded tech sessions beforehand as well. So there's lots of cool stuff happening in the month of October. Make sure you check that out. devsummit.arm.com. Another thing I want to touch on is the Dev Summit developer competition. And we'll also put that link up here. You can go to developer.arm.com/devsummit-competition and go check that out. I think there is still an opportunity to enter into this competition. It concludes around Dev Summit. So there's still about less than a month or around a month left to do this or get involved. But go check it out if you want to get involved, sign up and get your developing on, right? Lots of cool stuff there. Last but not least, and I'm not going to really dive deep into this one, but our guest, Gordon, is bringing or is launching or has launched a new Kickstarter campaign. And so he's going to join us and talk a little bit more about that during the main segment. And I think that's the perfect segue to bring Gordon on. So let's welcome our guest onto Innovation Coffee, onto the show. Gordon, welcome. How are you?
Hi. Thanks. Good. Thanks.
Excellent. Cheers.
Yeah.
We go like this. We go clink. Yeah, there you go. So welcome to Innovation Coffee. You and I have not had the chance to meet in the past, so I greatly look forward to kind of getting to know you and hearing all about the cool stuff you're working on with Espruino.
Thanks.
So that being said, what we like to do at the beginning of every episode is talk about your origin story. So maybe you could tell us a little bit about yourself, what you do or what you did before Espruino, now with Espruino, get us up to speed.
Yes. So, I'm based in England, as you can probably tell from the accent. I kind of like to make things, and I kind of grew up in a family where we fixed stuff that broke, and we made new things, and that's kind of just sort of gone through most of what I do now. So I started off out of university working for Altera, doing doing a C2Gates compiler mostly. And then I went back to some other hardware stuff for another company. And and I've basically been working mainly on either kind of low-level graphics or compilers or interpreters and things like that. And I guess I've really liked I've really liked kind of dealing with things at a low level, and so like embedded, where you get to kind of deal with sometimes the mechanical bits, the electronics, the software, and kind of how it all goes together is works out really well for me.
Yeah, I would have never guessed that you like to make things looking at what's on your desk there. Just kidding. Yeah, you literally have probably a developer or a hardware developer's dream right there on your desk, the oscilloscope. And it looks like you pulled out some form of like old school Game Boy box from back in the day.
Yeah.
Let's you know what? People are asking in the chat, what a desk, Gordon. So let's dive right into the Innovation Coffee Cribs. Innovation Coffee Cribs, where we explore the cool stuff that our guests have in and around or on and around their desks. So, Gordon, what do you got to share with us?
Okay, so I mean, there is a bunch of kind of random stuff here from, a mix of kind of very low tech stuff to some slightly higher tech things. So we've got, obviously, there's an oscilloscope, which is not a kind of cutting edge thing, but I sometimes use it for power draw or for debugging I2C, stuff like that. We've got the soldering iron, which to give you some idea of the family I come from, this was my 7th birthday present, and it's still running and kind of being used for pretty much everything I do. But yeah, the thing you mentioned is, I always find this like, I've been doing some things with NFC. So for these little Puck.js devices that go in a case and some other things, and I could never find a nice way of tuning them to get the correct capacitor values. And it turns out that the solution to it isn't, I mean, it can be your like £10,000 Tektronix oscilloscope, but it can also be a sort of 70 quid kit from the 1950s or 60s from eBay. And it's called a grid dip meter. And these things, you put a tuned area in, and there's a little oscillator, which is the frequency is controlled by that knob. And this shows basically the amount of, this one shows the amount of power going into the circuit. And so when the thing you've got under it starts to oscillate, the amount of power that you need to make it oscillate just goes right down, as in it dips. So you just move this very carefully around until it dips, and then you find out the value. And then a few different readings with a few different capacitors, and you can work out what the correct value is. And it's nice. It's such a really low tech solution to the problem, but it works so well, and it worked far better than anything I ever managed to do with sort of cores of wire and an oscilloscope and stuff like that. Because the second you put something else in the way, that changes the resonant frequency. So you may get it perfect, but you take it off and then it doesn't work because the probes that you were using just changed the frequency just a little bit.
You called that a glit bit meter?
A grid dip meter.
Grid dip meter. Okay. Those are other words I had not heard of. Excellent. Yeah, I genuinely thought that you pulled out a Game Boy. I thought that was, I thought you were going to get one of those old school gray Game Boys with the green screen on it and everything. But no, that's really cool. And I think it's amazing you still have the soldering iron from your 7th birthday. I didn't know that they could last that long. Have you had to do any repairs to it or make any repairs to it?
I think I had to change the plug because the grounding pin fell off it. But
gotcha.
Other than that, that's the only thing.
That's really cool. Very cool. Very cool. Awesome. Well, Gordon, it was a pleasure getting to know you, seeing what's on your desk, hearing about your origin story. So let's dive into the main segment now. And I mentioned during our news announcement that you recently launched a Kickstarter campaign. Could you maybe talk to us a little bit about this?
Yeah. So So I guess when I started off doing hardware, which we'll come into kind of what Espruino is later, I made little boards like this with a little prototype area, and then like they slowly ended up moving, to things like this without the prototype area, and then pins soldered, and then things like the Puck.js, which is actually just like a little device. It still had pins, but it was in a box, and it's kind of getting more and more consumer friendly. And like, I did the Puck, and then people came up with a like a little 3D printed case that you can put the Puck in, you can wear it on your wrist. And more and more people started asking, how can I have something that I can program myself really, really easily and stick on my wrist? So about 2 years ago, I did something called Bangle.js, which was this thing, which is effectively it's an off-the-shelf smartwatch. I say smartwatch. It was kind of a Chinese fitness band kind of thing, with a NRF 52832 ARM microcontroller, and yeah, it had really rubbishy software. So I basically ported the software that I do onto it, and we've kind of got this whole ecosystem of apps and stuff that runs with it. As you can see, this is kind of chunky. I mean, my arms aren't small, but it's still reasonably big on them. So I found a new one which is much better. It's got a sunlight readable screen. It's much smaller, much easier, and it's a 52840, which is like a Cortex M4 with 256K of RAM. So it's starting to be like a really useful little machine. So that's what this Kickstarter is basically.
Yeah, here. So I pulled up the window here. Can you see? This is the Kickstarter. That's really cool. It's sleek. It's compact. It looks a lot like the Apple Watch, to be honest. And I mean, people wear that very comfortably. So you got the design going on. You're pretty well backed there. What's your goal?
Yeah, so the goal was £8,192, which wasn't picked out of the air at all. But yeah, it's basically we're way over that now.
Very nice.
Like 3 times it. So yeah, it's definitely going ahead. The kind of weird thing is that because it's been so difficult to make hardware at the moment, and like trying to talk to the manufacturer in China, it's just really difficult to get up-to-date timescales. So I just ordered a bunch of them. So at least for the first set of rewards in the Kickstarter, they're kind of just, I'll ship them from here, and then the Kickstarter is really for the software, to kind of, at the moment it is, it's slightly, it's a lot more complete than just a dev board that you put on your wrist, but it could be an awful lot more. It could be getting near like, the Pebble kind of experience. And that's really what I hope this Kickstarter will allow me to do a bit more.
So we have a question here from Arjit. He's asking if the device can be controlled using JS. Is that why, what's the idea behind the name? Is that why?
Yeah, absolutely. So, I mean, I think we'll go a bit more into the kind of technology behind it, but it runs a JavaScript interpreter called Espruino, and the name is it's a kind of mashup of Arduino and it's sort of espresso for coffee, which obviously has the Java connotations. So it's not the best name ever, but it seems to be quite memorable, and I'm stuck with it now because we've had it out there for about 10 years.
Well, let's talk about Espruino now. That's my next question. Literally, what is Espruino? Introduction to it, please. Like, if you wouldn't mind, paint us that big picture.
Okay, yeah. So it's a JavaScript interpreter that runs on microcontrollers. So it's got really, really low requirements. It will run on the microbit 1 along with the Bluetooth stack. So that's 6 kilobytes of RAM, including the stack that you've got. So it does that by not trying to compile your code into some kind of bytecode. It actually executes it as it goes along, which is not super fast, but but actually an awful lot of the time you can use, you're using JavaScript functions like map and built-in functions, and a lot of the work's just kind of done for you by optimized native code. So it's aimed at microcontrollers, ideally 32K to maybe 128K of RAM. So they're really clearly in the sort of $1 to $2 range. So it just makes them an awful lot easier to program.
Very nice, very nice. And so, I mean, I guess I do have a lot more questions here about Espruino, but I do also have on my list here a short demo. So, we know what Espruino is now. Could you show us a little demo here, get us up to speed on that?
Yeah, sure. So, right, I will just try and adjust the camera a little bit so we can see a board. Oops. Second.
There we go. Wow. Okay, cool.
Okay. Now you get to see all the rest of the rubbish that's in my room. So
it looks a lot like my desk.
Yeah. Okay. So what you're seeing here is can we get it to focus? Yeah, there we go. Okay. I'll just turn that off. Okay, so what we're seeing is this board is Pixel.js, which is an Espruino board. But the important thing is this, which is one of the little it's a board out of a Puck.js, and there's a little PCB in there that is effectively, it's just running it from here so we can measure the power draw. So this thing's just booted. It's drawing about 25 microamps. So if I try and share my screen, sec.
Let's get this set up like this. So we'll move you over here. Bring this in. Actually, we can go like this. Let me see. Okay. There we go. That's perfect.
Great. Okay. So this is what we call the web IDE. It just runs a simple kind of HTML website, and it uses something called Web Bluetooth. So you just click this. It all happens in the web browser, so you can run this on pretty much any computer. And if I connect to, I think it's this one. So we'll see. The second I do this, you can see that the power usage goes right up to 0.5 milliamp, because now it's running a kind of a higher speed Bluetooth connection. And for example, if I just turn the LED on, I now have a console on the left-hand side of the IDE that goes kind of directly into the puck. I'm actually talking to the microcontroller. So if I run LED toggle, it's lighting it up, and you can see that the power draw from just lighting the LED is like 9 milliamps compared to it's 0.5 milliamp when connected, and even less before. So, I mean, maybe you think the power draw is too much here. You can change the connection interval, which is the Bluetooth. It's kind of how fast it pulls the data. So I can just send the command and I'll set connection interval 200, and now hopefully we'll see that power draw drop right down again, and it's gone down to sort of 25 microamps again. So it's really about just being able to kind of get this connection into the micro and to be able to see what it's doing and prod it. So, I mean, this code on the right-hand side is just a simple flashing LED thing. And all the scheduling is handled for you. So if I were to do this, it won't show up very easily on the power meter. But effectively, when the LED is off, it's going back to drawing virtually no power. And then when the LED is on, it draws a bunch of power. So it's just kind of the flexibility to fiddle around and actually, while the code may not be as fast as C code, by being able to experiment and try different things, you can often kind of get the power consumption down to a level near what you would have got with C, but in an awful lot less time.
So, okay, so this is kind of a perfect time, I think, to talk about this particular part of here. So you have this microcontroller or this device connected to Bluetooth, and then that screen you have is just basically kind of giving you readouts as you start adjusting certain things on your device, so that we can see that. I'm curious, like, what you're using this web IDE. This is something that you and your team developed. What were the use cases that you were looking at when you were originally developing this? Like, why did you decide to create Espruino to offer these types of tools to developers?
Okay, well, I mean, really, it was, and I've been doing stuff with microcontrollers for it's probably about 20 years now, since kind of the microchip picks. But when I started Espruino 10 years ago, I just started seeing these amazing ARM microcontrollers coming out. Like, I open my drawer of random microcontroller bits, like these, SD discovery boards and things like that. But it was really unfriendly for developers. So pretty much all the tools were Windows only. They were feature limited in some way. And obviously the proper version that wasn't limited cost you thousands of pounds. And I just have this memory of, I forget which board it was now. I got it out of the box. I was like, wow, this is really cool. I'm going to compile a sketch to just make the LED blink. And it took me 4 hours to download all the software, install it, set it up. And I finally got it to blink the light. And I was just like, oh, right, I'm done now. Put it back in the box, and it's probably stayed in that drawer gathering dust since
the discovery board.
Last 10 years.
You said you can't remember which board this was.
I can't remember which board it was, but it was probably something like Atolic. But 10 years ago, I think Atolic have since been bought by ST, and the situation is much, much better now. But basically, it was this frustration of one of my users called it the time to blink, which is basically like the time it takes you when it comes, you get it out of the envelope to when you can actually first blink a light on it. So the kind of the driving force behind it really was trying to get that as low as possible. And originally I started off creating software for the ST discovery boards and other boards like that. And it's not great because you still have to get the board out and you have to flash the firmware onto it somehow. So you still have to know a few things about it. But if you get a board with this interpreter pre-installed, you literally just get it out, you go to the Espruino IDE website. In fact, it's got NFC on it. So you get it out of the box, you put the battery in, you tap your phone on it, bang, you're on there. You hit the upload button, that's your flashing light straight away. So you can be doing it in way under 5 minutes. And really it's about that. It's about really lowering the learning curve to get stuff done.
There you go. Yeah. And I mean, we have some questions about the whole low code, no code aspect of this, right? But let's get a question here from the community. Sandeep Mistry asks, we've brought up JavaScript interpreter. You've mentioned it. Did you actually make your own JS interpreter for Espruino?
Yes. Yeah. Okay. So it's one of those things where the situation has improved drastically in the last 10 years as well. But when I was looking at this, there really wasn't anything that was desperately usable. And I had actually made a very basic JavaScript-ish engine for a music visuals plugin that I've been working on. And I thought, oh, can I port that over? And in the end, I ended up completely rewriting it. And I was aiming for a microchip pick, and I just found that the tools were too bad for it at the time. And I ended up moving to GCC and ARM, and I've basically been there ever since. But it does. The Espruino interpreter is most of ECMAScript 5, several bits of ECMAScript 6, but because of the way we interpret code, some of the things don't really make sense. And it's kind of like in terms of what's out there at the moment, you've got JavaScript, you've got duct tape, you've got Node.js, V7. There are a whole lot of different things, but they all do tend to target like kind of 128K minimum. Whereas, when Espruino's, you're talking about less than 6 kilobytes of RAM minimum. there's a big difference in terms of the trade-offs you have to make. So Espruino is very, very good with memory. It's not so good with CPU usage, but it depends on your trade-offs.
Yeah. Oh, there's always a trade-off in this world. Yeah. So I can see how we may have confused some people because, we talked about what is Espruino. Then we dove into a demo. We showed the Kickstarter with this really cool, wrist wearable. So I can see why Hybotics is asking this question. Espruino is a JavaScript device. I think it's, I'll let you answer this, but it's not just it's not a device, right? Like there are devices. Go ahead.
Yeah, so Espruino, it's a open source firmware that runs JavaScript. It's a JavaScript interpreter, and it's available for a whole bunch of devices. So because it's open source, I don't make money off the interpreter. I kind of manufacture and sell devices that have it pre-installed that are kind of really easy to get started with. But for instance, if you want to use a discovery board or a ESP8266 or something like that, you can get the firmware, you can put it on there yourself, and you can get started. But your experience isn't going to be quite as nice as if you use a official Espruino board or Bangle.js, where like I've been able to take the time to really make everything kind of nice and smooth.
Nice. Okay, so let's get this last one in here. Same viewer here from Hybotics. How much of JavaScript is inside Espruino?
So there's a page called espruino.com/features where it lists basically all the features that are in there and that aren't. So it's most of ECMAScript 5 spec. It doesn't have things like the Unicode, just because it doesn't make a huge amount of sense when you don't have that much data or that much user interaction. There's like in Bangle.js, there's no point me having Unicode when there's not enough space to store 65,000 characters of different languages. So we have here you go.
Yeah, lots of stuff. So they can go check that out.
The main idea behind it is if you are writing normal JavaScript code, you are not going to notice that anything is missing. There are a few like very random edge casey things that you might hit, and especially now you've got ECMAScript 7. Things it does promises, but it doesn't do async functions yet. Or destructuring, but these are all things that may well get added in the future.
Awesome.
And the nice thing with JavaScript is that there are whole tool chains out there that allow you not only to compile different languages into JavaScript, but they also allow you to compile newer versions of JavaScript into older versions of JavaScript, which people do for browser compatibility. So the fact that it's missing some of these things isn't a big deal.
Hybotic says he understands now. So we did our job. Okay, cool. Next question on the docket here that I have. Actually, I have two, but I think let's just jump straight to this one. We've been saying JavaScript a lot. What's the difference between developing in JavaScript versus C++?
So, I mean, I think the main one for me is that often with C, I feel like I'm literally interacting with a black box. It is the little chip on the processor, and little chip on the board, and I have no idea what's going on inside it. I've kind of lost track of the amount of times I have a new bit of hardware, I have the chip, and I can't get code to run on it. I can't get even the most simple blinking light example to run on it. And you don't know whether it's a hardware problem or whether it's something to do with the debugger or whether it's a tool chain or whether it's a bug in the code that you've done. You've got the pins in the wrong place. So developing in JavaScript, it gives you this interpreter that's running there with kind of like a command interpreter. So you've kind of got that whatever. And if you haven't got that, it's probably something really simple like power or clock or things that you would generally check as a matter of course. Whereas with C, you can implement things like that. Nordic's hardware abstraction layers got sort of plugins for a command interpreter and for logging all kinds of stuff. But at some point, you're just re-implementing your own completely random language, and you might as well be using something standard that's kind of already been done for you. So yeah, the other thing is that because it's running under an interpreter, you don't have the issues you don't have to worry about buffer overruns and stuff like that. And if you get an error, you actually get a stack trace. And that stack trace is a stack trace that you can capture, and it'll back out of executing that code, and then it'll run some more code where you can handle that stack trace. You can send it over the internet, you can store it in Flash, you can display it somehow. So you can actually, like if you have something in the field, you can see if there are actual errors in your code happening, and then you know to deal with them. And you can find out exactly where they happened.
Great. Sorry, I was trying to kind of get a little more detail on some more questions are basically popping up in the chat. I'm trying to get some more details, but overall, it looks like people are enjoying these answers. So great explanations on everything so far. Another one from Hybotics here. He's asking, is Espruino a subset of JavaScript like MicroPython is a subset of Python?
It depends on your it depends on your version of JavaScript, basically. So if you're going for, I mean, if you look at that features page, if you look before ECMAScript 5, you find that basically everything is supported. There are some really dodgy bits of JavaScript that I wasn't even aware existed before I started having to study it in great detail. And some of those, like automatic semicolon insertion, are not implemented. So again, generally, any normal code, if it passes a linter, which is there to detect dodgy bits of code, then you're pretty sure it's gonna run fine on Espruino.
Awesome. Hopefully that answers your question there, Hybotics. So there's another question that came in. I'm asking for a little bit more of a detailed question there. So let's see if Mark comes back with that. Now, I want to dive into a new topic here, right? So this is a discussion around IoT embedded development, and we're going to address kind of this whole low code, no code movement that's been happening. Now, I've talked to several other of our guests that came onto the show. Like, are we transitioning more to a low code, no code type world for developers? Like, are developers on these lower layers, these lower levels, kind of going to slowly start disappearing? Are we going to end up with a backlog of careers that people no longer have anymore, or whatever? We'll I'm asking you these questions here. I want to know, like, with this trend moving towards low code, no code platforms, why are they so important today? So maybe you could tell us a little bit about this.
I feel like there's there's obviously a lot of worry about security, and the more code you have, the more surface area there is for attack. The more stuff there is to test. And if you can lean on a library that does something that you trust and that is tested, and especially if it's out there and a lot of people have used it. So Espruino, for example, there have been at least 3 or 4 separate groups of people that I know have been sort of running fuzzing attacks on it. So, all those things that they found have been fixed. And you just wouldn't get that if you wrote code yourself, especially if it's kind of internal, unshared kind of thing. And the other thing is, I think it's just hard to find developers. I don't think that job of a low-level developer is ever going to go away. But at the same time, there are a lot of people want embedded stuff done, and there aren't enough people to go around. And if you get someone who's not very good, it gets very, very expensive if you've shipped out lots of hardware into the field. It's not like a website where you can just push it again. Maybe you've lost a few hours or days of customer interaction if something really badly went on. But once you've actually given a product to the customer, it gets really expensive get it back and do it, or send a replacement and swap over and all the rest of it. So yeah, it's important you get things right first time.
Yeah. I just feel like slowly but surely we're finding kind of like, the developers and even like classes in school, they're slowly moving away from these low level classes or careers like assembly. Like, how many people are actually programming in assembly nowadays versus the people who are using Python, right? And so, as you kind of like go up the layers here, you're working with these interpreter languages that are pushing everything down into these lower level languages. And at some point, how much optimization can be had at those lower levels that are really going to matter, right? Might as well just use an interpreter.
Yeah. And I mean, so I think in education wise, I think it's a massive shame.
Big time.
That people aren't learning how the hardware works, because like I guess my interest in compilers happened because I was really interested at seeing what the code I wrote actually turned into, and if and that meant how to write better, faster code. But it's also just really interesting to see what happens under the hood. And if you don't know that, even say you can teach about big O notation, and there's sort of this idea that algorithms have different algorithms take different amounts of time depending on the type of algorithm. But yeah, if you're not really aware of what your code's doing, you may not be aware that that doing a find on a linked list is taking you an amount of time proportional to the length of the linked list. And these things are, they can result in, especially the amounts of data people are looking at now, they can result in really, really big delays and really slow code and stuff.
I remember when I was in university, I took an ARM assembly class, and I think they gave us like 30 registers. Gosh, I can't remember, it was so long ago, but they gave us a certain amount of registers that we could work with. And for the final, our final was to write by hand, right? Like, we didn't get to do it on a computer. We had to write the code by hand to do the Fibonacci sequence. So, you had to pull things in registers, push things into registers, out of registers, do all this kind of crazy stuff to get the Fibonacci going. That was the extent of my class. I don't know if that would have been considered advanced or not, but that was the only kind of assembly education that I got. And now we got to do some labs too, which were pretty cool, right? Lighting up LEDs and doing all sorts of cool stuff on a little device. All right.
So just to add, if you don't mind, that I use the right tool for the job. There's while it's good to know how things work, if you optimize stuff all the time, then it's you're making yourself huge problems of maintenance and making everything slower. So it's like and that was kind of the approach I'd hope take with Espruino, is that that you write code in JavaScript, you find out which bits are slow. Maybe you actually just write those bits in C. You can easily write like inline functions to just do something that needs to be fast, and the rest of it can just be done in JavaScript, and it could be safe and quick to write. Yeah.
So let's look at Espruino as a community, as a developer ecosystem. And I have a question here: is what have you seen any increases in users? Is your ecosystem growing?
Yeah. It's it's been surprisingly good, actually, especially over lockdown. So I think the Bluetooth stuff, a few years ago, I ended up starting to move to the Nordic NRF52. That again, ARM Cortex M4s, but with Bluetooth on board. And it's just a really good fit, because Espruino was always really about like trying to schedule tasks when you need them, like on events, rather than just looping around all the time, and trying to get that kind of low power consumption. So yeah, it's where was I going with this? Yeah, so people have found that kind of useful. Bluetooth is really steep learning curve, so people have been moving onto that more and more, I think, because it's just very difficult to get started with the other tools that are out there. but there's been, because of the Bluetooth stuff, there's been a lot of people doing trials for contact tracing, health monitoring, stuff like that. So that's all kicked off. And then component shortages just mean that people, maybe you could have made your own hardware, and you would have done in the past, but you think, actually, I'm just going to buy it in now because because it's just so painful to source all the components.
Yeah. And so, I guess maybe a message for the people watching right now, you can go to Gordon's Twitter handle over there at Espruino. Where's another place? Like, are there any other places? Espruino.com. You have at Espruino on Twitter. Are there any other places where, your community can kind of congregate and hang out and get support?
Yeah. So the main one is there's a forum.espruino.com. And there are now about getting on for 50,000 posts on there. Wow. All kinds of things. I spend quite a lot of time, trying to be around to help out with any issues people have there. So it's hopefully it's a kind of nice, inviting place for people to go for help.
This is what we're looking at right here?
Yeah, yep. There's a split of kind of official boards, and then official ones are the ones where I sell them. I actually tend to offer a decent amount of support for things. Other boards like ESP32 that I don't make anything off. The forums there, a lot of members of the community are there to help out, but I don't generally put much time into helping those out. But yeah, it's hopefully it's a really, really good source for information.
Forums.espruino.com. All right. So everyone write that down in case you have any issues with working with Espruino. All right. So I think we're down to kind of these last questions here. Where do you see Espruino being used today? So like we kind of talked about all Espruino, what it is. Like, I mean, are there any products or stuff out there besides your own Kickstarter that like we might walk around and say, oh, I had no idea that Espruino was in that?
So the one that jumps out, which is very dear to my heart, is there's a really cool I can't remember what the name of it is now. It's basically an alcohol meter for beer. So when you're home brewing, you put it in, and depending on how much alcohol is in your beer, the kind of specific gravity of the of what's brewing, it tilts one way or the other, and it measures that with an accelerometer. That's cool. Made by Baron Brute. That itself doesn't use Espruino. I think it was almost predates Espruino, but they found the signal strength wasn't very good on it, and they needed a way to make a little Bluetooth repeater, and that they weren't expecting to sell them in huge volumes. They just wanted something to kind of enable this other product. So they made a little prototype using Espruino and one of the breakout boards, and then they actually sell it in like in a little container. And I think, like a lot of these things, they did that for quite a while, but then they reached the volumes where it's worth actually them installing actually making their own hardware. They made their own hardware, and they're still using the Espruino interpreter in that. Nice. But it kind of shows this progression of what you can do, and because it's open source, it now their costs, they don't have any licensing costs for doing that. But other people use it for research. There's quite a lot of things like just data logging, where you want to get data, maybe do a little thing with it as it comes into the device, and then store it. And especially if you're a researcher, you're probably not super into embedded development, so you just want something that just works, maybe has a file system you can dump stuff in. So there are a few of those. There's currently these little things out in on lions and wild dogs, measuring acceleration, and it's another kind of example of just trying to get something quickly with a kind of minimal effort that is reliable.
Very cool, very cool. So let's take some of these community questions. You still have one more demo, right?
Yeah, I can do. Yeah.
Okay, so let's take some of these community questions, then let's maybe close it out with the demo. I think that's a good order of operations here. So we have this question from Mark. He was asking back when we were talking about JavaScript, interpreter language, et cetera, et cetera. He's asking if you've ever encountered Forth, the interpreter language.
I have, yes. That is the one that's kind of, it's reverse Polish notation, isn't it? I think. So yeah, I just part of so that is, it's a much more efficient language to interpret, and it would be much faster and a better fit. But part of the reason for doing Espruino is to be a very low barrier to entry, and unfortunately not many people know Forth, whereas a huge amount of people know JavaScript from mainly from web development, and it's also, I feel like JavaScript is quite a friendly language, and it kind of it looks very similar to a bunch of other things like C, PHP, Java. So if you're just learning, or even if you're just used to looking at code in one of those other languages, it seems a bit more, it seems a bit easier.
Great. Okay. Well, hopefully, Mark, that at least addresses your question there. Hibonics asks another one here. He says, does Espruino relate in any way to the interpreters in our web browsers as far as feature sets go?
Yeah, no, it's pretty... so the issue is that the web browsers are constantly adding features. Like, they've got a team of a lot of engineers working purely on the JIT compiler and interpreter, like V8. I can't kind of keep up with that pace of progress. But if you look at an older web browser, I don't know, but maybe if you're looking at Internet Explorer or something, it's probably similar to IE9 or something like that.
Okay, cool. Hibonics, hopefully that answers your question. And then this is the last one we have here, and we can dive into the demo. It's from Sandeep. It says, what are some of the cooler Espruino community built projects that you've seen?
Yeah, that's it's really difficult to
maybe just pick two or one.
So yeah, there's one that always brings to mind, which it was just something I hadn't really thought of, which is an accessibility thing. Someone had one of these little puck devices, which are like little smart buttons with a sensor in and some other stuff. And he had just gone in for some surgery, and he was basically bedridden and couldn't really move. So he turned it into a kind of automatic page turner for his tablet. So it can be a Bluetooth HID device. So it's only like 10, 20 lines of code to make it be this device, and depending on how you press it, it either steps forward or back or does something else. But there's this little thing that he could do that like made his life a million times easier. But there are like there are significantly bigger robots. I believe there's like a canine robot from the old Doctor Who that uses little bits of various Espruino like controllers and things in it, and yeah, there are loads of different things, and often you don't hear about the coolest things until you're just talking to someone and they're like, oh hey, I did this. There's a taxidermy squirrel that its eyes light up when your build fails, and these really crazy things that yeah, you're just talking to someone and they're like, hey, I did this.
That's really cool. That's really cool. I think that's probably some of the funnest parts of the job, huh? Finding out all the cool things that people are building with the things you created. So that's cool. So yeah, thank you, Hibonics. I want to thank you very much for joining us. He's saying it's a really good stream today, and many thanks to both of us. So that's really cool. So Gordon, I think let's close this out. We have about 7 minutes left. Maybe you can show us this last demo. We'll give you an opportunity to drop your shameless plug, and then we'll close it out.
Okay, so I'll try and program this now. We'll see how I can get the camera set up for it. But let's see.
You're gonna this is the same device that's on your Kickstarter, right?
Yep. So let's see if I can get the camera to focus. Not the best start. Come on.
I think it's all right. We can kind
of. There we go. Perfect.
There we go. Nice.
Okay, so I'm still showing that window, aren't I? So let's see if I can pull this up. Make that a little bit bigger. Okay, so now this is exactly the same window that I was using to program the puck. But if now we instead connect to the Bangle.js device, which I think is this one. Let's see if the Bluetooth light lights up. Nope, it's not that one. Okay, so we're now connected, and in much the same way, like I can write code on the left-hand side. So if I send this code, there's a little fake LED that lights up just in the top of the screen that you can see there. But if we want to do something a bit more interesting, maybe we want to make a temperature sensor. So we can find out what the temperature is. Let's say e.get temperature. So I think this one's coming from the processor itself. So we can quite easily just write, there's a little graphics library on here. So if I'll just pull this out into a function. So first we just say g.clear, and we'll get the temperature. And we'll turn it into a just a sort of fixed point number. So with 1 decimal place, and then we just draw it. Okay, let's just draw it in the top left-hand corner. Hopefully, that's now absolutely tiny. You can hardly see it. So what we can do is we can experiment. We can just change in the font. There's a vector font, and we'll try and make it 20 pixels. Make it a bit bigger. So this is the kind of thing that you might expect to see on a on a computer with some kind of operating system, but it's you're doing it on a 64 megahertz.
And you're not
Cortex.
You're not plugged in. This is all just being programmed through Bluetooth.
Yeah.
That's really fast too.
So that's now aligned it to the center. So we'll whack that on there, and we'll just whack it in the middle of the screen. And we can build up from there like much easier. But the nice thing is that you've got this kind of mix of writing code on the right hand side with a proper editor with little code hints. Or you can kind of tweak the code while it runs. So say we want to do a graph. So let's add a little array in here. Okay.
Does it have a little speaker on there? Is there any sound that can be emitted from it?
It doesn't, but it has a vibration motor, and actually you can use the vibration motor if you pulse it at the right duty cycle. You can use it like a reasonably quiet speaker.
Yeah, John is saying that you should program it to play Manic Monday on Mondays.
And I believe there may even be an app for that. I have heard one playing Manic Monday, so I don't know whether it's been published yet, but there definitely is one. Yeah, so let's. So I can't remember exactly whether it's shift or unshift for arrays. So again, you can just kind of try stuff out. So I want to take something off the front of the array. Is that right? Yeah. Nope. So it's actually array.shift. Took it off. Okay. So now we at least should have the data in the in there, and we can just do let's use sort of define a function for it. So you can do arrow functions, for instance. So we can get 2 values of the arrow function there, and then we can choose. We can just do line to. And this is actually going to be really boring because the temperature is not going to change much. But I mean, And then I'm just hard coding values in here just to get something that you can see. So now if we try to do this, again, I can replace this function and know that the history has been previously recorded. So if I put that on there, we should see, what have I done wrong here? And this is where we think, 106 over x. There you go. Now you get the temperature graph. But that's done very, very quickly, sort of just nice iterative programming. And while you don't, this actually has SWD pins on the back of it here. So you could program it with wires if you wanted to.
Nice.
But there are cases when you want to do it wirelessly, especially if you're dealing with hardware. Sometimes you really don't want to attach your £1,000 PC directly to your bit of hardware that's also plugged into the mains. And bad things can happen. And this way, you know that there's no physical connection.
Yeah. Well, it looks like people that are viewing really enjoy this as well. Roger even owns the Bangle.js V1, so he's waiting for his second one to arrive.
Brilliant.
That's cool.
Thank you.
Yeah. So there is one question from Roger actually, and I think we'll close it out with this and go into your shameless plug. So Roger's asking, are there any examples for TensorFlow usage on the Bangle.js?
Yes, there are. So there is a whole. So Bangle.js, the first one was actually launched at NodeConf.eu, and we did a workshop at NodeConf.eu, and part of that was a Google Colab worksheet showing kind of how to do gesture recognition. So there's that whole Google Colab up there where you can kind of work through training a model and also uploading it to Bangle.js, which again you can all do wirelessly, and you can upload models and things without even having to reboot it. So it's kind of quite nice and easy to play around.
Very nice, very nice. Cool. Okay, well, we're at the top of the hour now. I want to make sure we don't take up everyone's time. I know your time is very valuable. So real quick, Gordon, do you have any last words?
So shameless plug. This Bangle.js 2 is on Kickstarter at the moment. If you're interested, check it out. Otherwise, have a look on the Espruino website as well, because there are lots of cool products there. Even if you don't want to get one of the Espruino devices, you may well have a microcontroller board that it will run on, and you can just give it a try and see whether you like it or not. There is also an emulator for the original Bangle.js that runs entirely in the website. So you just go to espruino.com/IDE. You can try out kind of like I did with the temperature graph, just on there from the comfort of your web browser. And in a few weeks, I will modify that to include an emulator for the Bangle.js 2 as well, so you can try stuff out for that.
Very cool. So you heard it. Go to his Kickstarter. I know several of you already in the chat have mentioned you're waiting on your V2 to show up, so that's really cool. If you've already supported the Kickstarter campaign,
Thank
awesome. You. Yeah, go to Gordon's Kickstarter campaign. We put it down there in just a second. We'll also include it in the description, and support the campaign. Number 2, check out Espruino.com. Looks like a fun site to go explore. Lots of cool stuff to experiment with, and it seems like a lot of you all that are watching are interested in this kind of stuff. So that's amazing. Gordon, gosh, thank you so much. I really appreciate it. We appreciate having you here. This has been great. So thank you so much for your time. Yeah, no I'm gonna close this out now. Y'all ready? Okay, here we go. Gordon, thank you. Everyone watching, thank you so much. If you're watching this on demand, we appreciate you as well. Hopefully you enjoyed this entire conversation. You were able to stick around for the whole hour. If you did enjoy the video, it helps us out a lot. Make sure you hit that thumbs up button. Like the video. There's 14 of you watching right now. All hit that thumbs up button. Like the video. Follow us on ARM Software Developers, the YouTube channel. Make sure you go follow at Espruino over on their Twitter channel. Go check out their website. And we will be back next week because we do these streams every single Thursday at 5 p.m. UTC. You can join us. If you're subscribed, of course, you can make those notifications known. All right. Well, thank you very much. Y'all have a wonderful rest of your day. Let's close this out. Thank you. Take care. Have a nice one.
Thank you.
Bye, Gordon.
Bye.